Okay, thanks a lot for joining us. And today we start the first session of our design pattern course. And first of all, let me introduce our speakers, especially for those who joined us for the first time. So my name is Arina. I work as VP Lead Software Engineer at JP Morgan Chase. And I ex-Revolut for 3 years and ex-Yandex Registration Google. So I've built a lot of software and I've met almost all patterns that we can find in this book and even above this book. And our volunteers will helping us to bring these sessions to be alive. Sonali, who is senior engineer with 14 plus years of experience for e-commerce solution. And Leslie, who full stack developer for 5 years of experience, and she's specializing right now with Python and Django. She also studied with patterns with us, and she helped us to make this as much accessible as possible. So she always question, okay, how it will work actually in Python, how to explain this better. So we hope that these sessions will help you to build very strong foundation of design patterns. You will be fluent in this, and you will challenge your colleagues as well, and you will feel much better and much more professional developers. Let's refresh what we discussed in the previous session. Who would like to share why do we need and when do we need observer and decorator patterns? Maybe we could start with observer. Anyone would like to raise hand? Do not hesitate. Okay, I will try to find a volunteer. Isabel.
Hi there. Observer. So I remember that we wanted to use observer in situations where we needed to notify other objects. So that's usually a case where we would use that. With Decorator, the impression that I get, can I speak about Decorator now? What I can remember.
No worries. It's absolutely correct for observer when we would like to notify one object or subject about another subject. We can use observer as a pattern, and that to simplify decoupling, like decouple them. Well,
I don't remember exactly, but I think we were talking about different payment types when we were talking about Decorator. So maybe we use Decorator when we need to have multiple entities of different types that can be used by the same service, something like that.
Almost, but it was strategy when we talk about different payments systems like MasterCard, Visa, or PayPal. We were talking about different strategies to facilitate the payment. You have one account that you can have 3 strategies to pay through this account. We have a hand from Pradney.
Well, I think decorator is when you have a class defined and you want to apply more functions to it, but it needs to be at runtime. That's where I think the decorator can be used.
Yes, so decorate is a functional with several more layers. Narmi, what would you like to add?
Hello. I want to add more explanation regarding decorative pattern. So what I understood from the last session, it's kind of allows the extend behavior of the implementation without actually modifying the previous implementation. So we hold the reference to the base class, and we are wrapping around the base class by extending in this way, extending not actually inheritance, but with wrapping around, we are extending the behavior of class and enriching its functionalities basically.
Yes, correct. We not only add new layers for one functionality, which could be login, authorization, tracing. We also do this without changing this functionality at all. We just put the layers through decorator pattern. We able just to add layer, and this will be decorated in runtime without changing the original implementation. So yeah, thanks to everyone who they have a word. And I hope next time something like someone else will be brave enough to share their ideas. Okay, let's go for today. So as you read in description, we are going to talk today about creational patterns. And in this book, we had several patterns to be chapter by chapter. Basically, next chapter was about factory method, abstract factory, and singleton, and also prototype and builder. You can find them as other patterns at the end of the book. So don't hesitate to go to the end of the book to page 600 and next to check what was there about builder and prototype. And today we're going to look precisely at these patterns and look at examples and look at more real-time examples. So let's start with factory methods. Who can share with us any ideas that they get from this pizza factory class, or from these ideas around baking pizzas and simplifying the process in the code base? Yes, Nermin?
So basically, the class that we delegating the creating the objects to the simple factory class methods. Basically, we are hiding implementation details under the factory method. But we can also extend this behavior. We can use factory pattern, which is kind of the interface, and it can has different implementation. We can delegate, the creation of the object process to those classes, to those concrete classes, basically.
Yeah, that's correct. So instead of having in one class all different choices, how exactly we can create pizza? Should it be cheese pizza? Should it be pepperoni pizza? Should it be clam pizza, veggie pizza? We put it in separate methods. So indeed, we hide details about implementation. So that's one method, and we call it factory method. There was a hand from Bubble. Would you like also to say something? To add something?
Yes.
Yes.
I think we said most of it. And then maybe one good way is that also all the things that are common can be put inside the pizza factory, and then all the things that vary with each different implementation, they can then be put in the actual instances.
Yes, it's a very good note. For example, if you have margarita and for cheese, you can reuse some ideas around cheese pizza as well. And that's again will be hidden in this simple pizza factory. That's a very good point. If pizza seems to be too abstract and high level example, the idea that I would suggest, think about your database that has several tables inside. Yeah, and you can build different repositories. For example, you have product with users, with products for those users, user addresses, what else? Discounts for products. So basically, you can have one database with several tables, yeah. And to serve those tables, you use repositories, which will suit in your code base as repositories. So one of the implication of this factory method is to give you repositories. So these pieces, you can think about them as repositories. And I will put here class diagram. Just let me a minute to close the door, so it will be easy. Okay, so basically we say that creator of the product will have factory method, and that's it. Class diagram is called small and simple. You have basically two entities, two actors. That's here, like one is factory and another one the product that we'd like to create. That could be repository, user repository, product repository, address repository, something like that hide behind the table that serve your data. That's one of the examples that we're going to look today more to. Okay, so factory method defines an interface for creating an object, and let subclasses decide which class to instantiate, which implementation we would use. Abstract factory. So who can tell like what is the difference for abstract factory? Yes, Nami? Yeah.
Abstract factory, basically, if we have some family of the objects, like family, what I mean, the related objects, we can use in that case abstract factory. Basically, we are grouped into the one category, the objects we intend to decorate. So we hide all the implementation details in that abstract factory. And also it's it has also own concrete implementation, but here we are using composition, basically.
Yeah, so here we can say actually we have many similarity with how exactly we create pizza. We create doughs, we create sauce, we create cheese, but different factories. Chicago and New York will do it in different way by giving you a bit different ingredients for doughs, sauce, cheese. Yeah, so that can help us to identify that there is a factory that can facilitate our different implementations. Yep, so if we go next, together they form diagram, which I would suggest to think about like they exist together. We can always have abstract factory, which has one implementation and another one. Example of factories for repositories, it could be one implementation for production and another one for testing. For testing, we give them stub repositories, for example. That could be an example. Or you could even define the class factory, which will have inside many factory methods. And that's another suggestion to look at it. You don't need to even have interface, but if you define the class that have many factory methods and build repositories, for example, we also call it factory. So we don't need to always follow interfaces. It's not that strict. We can just think, okay, this is our factory. And when we think about real-time application, we think about in the beginning of application, we say method main, And inside main, we build their factory that will have all repositories in place and, for example, all resources in place, all controllers in place. So those classes that will serve HTTP requests, that will accept HTTP requests, and will give response. So they also should be served in this factory. So you can think about one class as a factory that this class has all your factory methods for all repositories. Yeah, if you use very high-level frameworks like Spring, there is something under the hood that's happening that's already have these factories. Like it's use annotations, reflections, but somewhere under the hood, it's bring to you this factory. This factory give you repositories, controllers, services established, basically. Okay, so let's move next. And official definition from the book will be that abstract factory provides an interface that's creating families of related or dependent objects without specifying their concrete classes. It's like having the factory, yeah. And let me share with you my real life example. Again, we're talking about repositories. And here I would even suggest to think about interface to be parameterized with product, which is your DTO, which is entity that's basically different table. That's how we can do this in Java. We have repository have find by ID function and save functions. Basically, two functions that we need. Now, let's think about another one, user repository. Again, we find user by ID, we save them by ID, and also again, have a note that we have user as parameter, like parameterization of repository, which can get that we can get from Java because Java have this wildcards and typization. So we can say that our repository have type user and the user repository implemented. And let's see why. Because we can build our factory again. In real life, you don't have always Spring interface for this repository factory. You can just define a class, but again, everyone would understand what you've meant. If you want two different implementation, one for production, one for testing, you can do interface, implement this interface, and then it will be repository production factory, for example, and another one repository testing factory, which will give us exactly a more strict abstract factory pattern. We do interfaces as we saw on the class diagram, and we do two different implementations. However, if you put just repository factory class, everyone would understand what you mean here, factory, abstract factory pattern. So we know that's what we expect there. We expect setting up repositories. So what we do here, indeed, we put here it's even in static, because basically as soon as we build program, in the beginning, we build our repositories, and that's it. We can do it even all in static context of the class, which will be built before application will start. Yeah, and here we do the trick. We say there is a method get repository, and we define the repository depends on class. Yeah, and we return repository that serves the type of this class. That's why we've put the typization for wildcard for our product or user. Yeah, so that's very beautiful trick of guarantee that you always get the same type. And that's wildcards that's in Java that could allow you to do this. If you have any questions about this code, please let me know, try it on your own, see that it works. But that's a very good idea of providing supply. with knowing what exactly you have in the end. Yeah, so that's beautiful factoring method inside abstract factoring. Yeah, okay. Now, yes, Christian.
It's just not clear enough to me. What's the difference between factoring method and the abstract factoring?
Again, so the easiest idea to think about it, abstract factory have many factory methods. You do not put factory methods anywhere else. You do not put it regularly, many different in one class, but if you put them in one class, that's abstract factory. So basically factory to serve methods, factory to serve factory methods. So that's the difference. If in case of factory method, we say that's only the method that will basically serve it, then in case of factory, we say that it's factories that combine all these methods. So here we could have repository factory. We also could have application factory that could have many different factory methods. Not only get repository, but get controllers, get services, get HTTP clients that's going to go through application, get connections, get something else. So we either do several things in one factory, or we also can do several factories. So that's already up to us, like how exactly we design it. Yeah.
Okay, thank you.
Okay, good. Okay, let's talk about singleton. Who has understanding right now? Why would we ever even need singleton in our program? Why to guarantee that there is only one instance? Yes, Nani?
I have always used singleton pattern in the cases where we need only one instances of the objects, which are creation of those objects is very resource heavy. Like I can think of one vivid example is the database connection. I have always used singleton pattern there. I mean, because we only need one database connection, and we can then reuse this database connection in order for getting the objects for records from the database. That's why when the applications boots up, you can have there are lots of various ways to create actual singleton objects. We can use static, the keywords, or we can defer object creation for the later. Like it calls, I believe, lazy initialization. So basically, we defer the creation of the object when the client calls this object. So it's, I believe, called lazy initialization.
Mm-hmm. Yeah, that's
but
very
we
good.
have. Sorry,
Mm-hmm.
I forgot to add. But we have to again hide this object creation part. We have to add private keywords, and only inside those class we should create the object, and we should have only one public method, basically, to expose to public callers.
Mm-hmm. Yeah, that's implementation. That's great. So database connection is a very good example, because if you create several database connections, you may end up very bad for database, or either another instance even wouldn't be able to connect because first instance already built the connection. So for this example, it's indeed, you need singleton. It's a very good example. It's one of the most popular. Another could be configuration. Again, we need to read only one config. and you need to store only one configuration across the whole program. If something will be changed, it should be implicated across all objects and classes. And Pragna, you also had your hand raised. Would you like to add?
This
Yeah.
is a very old example. It might not be relevant today, but uh, there was a scenario when a key had to be generated within within the given context, and it had to it was like a count that uh, how many of those objects are being created in that one session or something like that, and that's where this pattern I had used. There was a
Yeah.
database object that would keep that count.
Yeah. It's not old. If you use metrics in your application, for example, Java wizard metrics, something like this, I definitely remember wizard in the name of this library. They have counters inside, and you can use these counters to check how many requests and response you could get.
Mhm.
But requests and response come in also in parallel in different threads.
Yeah.
So that would guarantee that you count them correctly. And at the end, you go to Grafana or whatever dashboard, and you see how many requests responses you have in a second. And Sanani, I think you also would add a very good insight for this.
Yeah, I think Narman can use that example of database connection. I guess that's a very relevant example, and that's the very straight away example where people can understand why would we need a singleton instance. And I think in Java context, a lot of applications would be using it for. I know that's like a very complicated concept of multi-threading, concurrency, and stuff, but I think that is one of the area that most of the developers would be using the singleton instance as well.
And in this example, they actually was talking about concurrency because they brought very funny example like this is chocolate boiler, but then two threads hit the instance without understanding that it's without singleton, it's leaked, and there was hot chocolate everywhere. So that's kind of idea. If you will have an access of two threads for resources that has to be only in one instance, and that will be disaster again. So it was like this picture that was the idea that it could be disaster at the end because also we work with multi-threading in application. That's already hidden for us by frameworks. A lot of frameworks already have all these ideas of how to get several connections, several request response at the same time. But we need to keep in mind that we're still responsible to understand how it works. And if you go to class diagram, I put here because it's my favorite class diagram. It has only one class. Singleton is have only one class, singleton instance. Okay. Singleton pattern, which means the class has only one instance across the whole application and global point of access state. If we just return to my example, here instead of new, we can put product repository, which will mean that you will get static public instance, which is private, because again, for this repository who will serve you this safe and find ID methods, you need one instance because you need always guarantee that it's the same database, it's the same database connection. So everything there are singletons. And for repository, we didn't. Yeah, we also put here new repository factory and put like that's what I do. I wouldn't use instance as a method name. I will put name always repository factory as it is. So I also put it as example. We have a raised hand from Sonali.
Yeah, I have a question that something came to my mind was like, maybe I'll explore more as well, but it'll be good to hear from someone on the call as well. If we have mistakenly used a singleton where we didn't want to, because that's the tricky part. Like it can impact your performance as well. Like when you wanted to have some parallel processing, but instead, because we were stuck of a single instance, then that is the drawback of using singleton pattern rather than going for an approach where you actually wanted to have multiple instances.
Yes, it will be very interesting to look at this precisely, what exactly happened, like how like design, if you follow design patterns and principles, to be honest, it's very hard to get it inside because your program design of basically two things, factories, repositories, controllers, services, which are all singletons, and your data models that should be immutable every time you create copy of data model when you want to update your record from database, or every time you create a new data object that comes response, transform it to data object as your internal representation, and then transform it to data object of your database. They all dynamic objects. They are not singletons. They all appearing as a new objects. Build it with builders that we're going to talk just in minutes, and then disappearing because we don't need them anymore, and Java machine will ruin these objects for us as well. So basically we serve some number of objects, and we may put them in caches also in between. And we will come to the pattern that I described, model, view, controller at some point. And I will again come to these examples of creational patterns, and we will see how they combine each other. Okay, so right now let's go to examples for singleton, and the same, you see the first several line database connections, the second configuration objects, the third resources, again, when you need to write to files, etc. And you need to accept requests, give back response. Let's talk a little bit about builder and prototype. And here is my example for builder. This is, for me, the best way to explain it. Basically, you have a product and you have many different fields. So I would like to ask, think about, you have product and these fields, ID, name, and discount. Yeah, maybe discount, I mean, later. First, you just put their ID and name. Now you want to put discount. If you don't use builder, if you don't use any pattern, you just use constructor, what is the problem that you need here? So if we know that in constructor we can, yeah, I mean, let's try.
Imagine we instantiate the object with new keyword and too many fields. It's verbose first, and also we are kind of again, violating this encapsulation. We are openly, we open our class to the, to the clients that calling it publicly. It's better we have builder patterns so that we don't need this verbose coding rights style, basically. And we are whenever we need, and also we don't need many the constructors when if we want with two properties to create the class, we can just use these two properties, or let's say we need all the properties again. we will use just one style in order to build our object rather than creating many constructors to instantiate each type.
Yes, that's a very good answer. So when we have constructor and we have many fields, and then even two fields, ID and name, and we need to add one more field, discount, we need to build another constructor. And if we think that it's important and we don't know basically what our clients is going to use, we don't know even maybe we need to deprecate the previous constructor. So basically put annotation, deprecate, and say, hey, stop to use it. We now have discounts. So to help to set this problem, we have builder pattern. If we continue to extend constructors, more and more different constructors, it will be very confusing. We can put in builder this field to be optional, but if we do constructor and we have another discount expire date, and then we don't know, like, actually, if we do even one more field, and then we understand that basically user can build discount without discount expire date, or they can build product without name, for example, and we can't, and we should give them like, I don't know, 5, 6, 7 constructors at the end. So instead of doing this, we can just duplicate all constructors, say that we have one constructor, it's private, and that will be used only by builder. Please reach me again for this example with more code that is here, because it's important point that I said that it's not on the slide, that constructor of product from you deprecated from, like you just can't do this, it's private again. It's private, but it's not single. It's allow you to build product only through builder. So that's why you can't use constructor anymore. You can create as many products as you want. It's not singleton, but you can build them only through builder. So here is example, like think car, which has several fields, and that's just like mark, model, those. Yeah, there was a question from Val. Yeah.
I was wondering, is the builder also a good way to, maybe if you have some logic you need to do inside the builder to maybe put something together, is that a good way to place some internal logic that maybe someone calling it doesn't need to know about?
Yes, and for example, you can have that your expire date depends on discount date, like discount, like when you put discount and no one put expire date, you can by default put their logic update like now plus 30 days. That will be your logic. So that's examples that you can put indeed. Yes, it's possible to use for logic as well. That should be logic that's about your model, how your model is behaving, because product is your model. Basically, think about business model, how it's behaving. And another good example that we didn't cover yet, that we will come to state pattern, and there I will share a link. That product can be activated, created, predefined, I don't know, like it could have the whole life cycle. It could be the same for user, like we can have user that's pre-activated, created, going through KYC process. And that's different states of this user. And all the states we manage as a logic in our builder, we say like in builder and on the data model as well. Like on data model, we are allowed to move them between states, but only if they at some state in the beginning. And in builder, we say first state always created. That will be our business logic inside builder as well. Yeah. Question from Anna.
it's not a question. I just wanted to add that I think also using a builder when you have these, so many fields in a constructor, then you have to remember even the order, and that can be confusing. Say, or you could, some. So if you're using like even numbers like integers, or you have to remember which is which and where it comes. Whereas with the builder, you don't run the risk of swapping and doing wrong things, basically. Yeah. So I think it's another.
Yeah. That's good. And in Builder, you can put that several things are optional. So you need to build only things that's required. There is another pattern that you can use, but it's much more complex. You can define predicates that force you to build only in particular order by builder, but they will give you also the type of the next object. Like it's more high level, it's more complex, but if you have very important business domain object, and if you use this pattern, it's becoming amazing. Yeah, Sonali.
I have a very small question, but like just to understand what would be the best practice to define a builder. Like in this example, in the previous screen example that you showed, you use builder as a static class. Like normal you don't need a new instance. By the class name, we can define all the methods and access everything. But
yeah,
but a lot of examples that I've seen in the actual applications, they use the builder as a normal class, not as a static class.
Yeah, I put this example and I didn't even put class diagram because class diagram again tell you that you can have interface builder, but because builder should be related to only one business object, I don't think there is any point to have interface for builder because you are not going to implement several builders. You need only one. And if you read Josh Blofer, I didn't read third edition, I read second edition. So that's how effective Java Josh Bloch recommend to do, like inner static class. And because it's inner, again, like no one is going, people going to use builder, but it's enough to predefine it as a static as context. And another reason why it's static that your method builder is static. Let me see if I can. No, I won't be able to edit, but I will enhance slides with more code from this one. Set in another environment. I will put like what exactly the method. The method is static because whatever you want to create product, you invoke static method builder, then you build with several instances, and then method build return you the product. So exactly this one. But the builder method, which I will call product again, because you're going to create product.id.name.discount build. So that's your product, and that's static class. You don't need the instance when you build them. That's why it's static. Daria, yeah, is I pronounced it correct?
Yes. I want to ask how do I know which builder methods to call when creating or when generating a new instance? Is that is the Java giving an insight about what methods are there so I can create on the go?
Yes. IntelliJ framework, it gives you after completion, like it's a like what is the next method, and mostly it can be any order, unless like you shouldn't skip fields that's mandatory. But if you do unit tests, you will find out you skip if you didn't initialize one of the field. Just simple unit test will give you like, okay, object can be constructed because this field can be null. So even if like there are two big class and you couldn't find resources like which one is mandatory, which one is not, you can do this unit testing. Another example I didn't put here, but what I used in the past, like for my clients of my product, I also built a product data class with instance with static methods, and they, for testing, for example, can just invoke this product data as an example for their tests. So that was just another layer, but that was just for testing test features for my clients. And I really like this approach. Sometimes, like, I just go into another repository and build, and I am client of my code base in another repository, not Steam repository, but I could even do it for myself, and I enjoy building quite quickly.
And sorry, may I ask a second question?
Of course.
Thank you. If the methods become long, does it become a disadvantage of using a builder? Like if there are like huge bunch of list of.
It's definitely better than having constructor with all these fields. And your model could be as complex as business need. That's true. So you maybe have a lot of optional fields. You maybe work with, I don't know, marketers who every day do experiments and they need different feature flags, and day to day say, let's add color to this. Let's tomorrow add something else. And basically through these builders, you can have like a lot of fields that you don't care, you just set up today what marketers need for today, and tomorrow we just set up new field. But if it's a business case to be quickly, faster, just to test on production, like if it works on A/B testing, yeah, that can save your time, despite that will be many fields. So your model could be as complex as business need. There is no limitation how many fields and how many internal objects your data model can have. But they're definitely better than constructor with all its fields, and then another constructor is just one more new field. Pratna?
I was just thinking of an example. I don't know if it would be a builder pattern. So in my previous experience, there used to be cases like this where we are extending, well, we're going bottom up, that the table is being extended to add an additional data, and in order to be able to minimize the number of changes in the application, we would make the construction of the objects using dictionaries, like key pair values, and it was those dictionaries that could be passed dynamically to handle it. But I'm not sure if it is builder.
I have two thoughts upon it. First of all, if you add new column, it's indeed could be facilitated through builder, because behind this product, think about table in database product. It had ID and name, and then business set. Let's add discount. And you add the default field discount, which will be a column in your database. And then they come and say, well, let's add expiry date for discount. And then you add new column. But of course, when you add it to database, most of products, they don't have yet any discount and expiry date. So it's your optional fields in Builder. Or like by default, discount is 0. Yeah, we could put here like discount equals 0 exactly in this place. So we don't care, like no one put discount at 0. If there is expiry date, it's null because no one yet know about expiry date. So that's about tables. But another thing, what if you need more dynamic attributes and key value pairs? Then you add to table the field that has, I don't know, JSON, for example, JSON being Postgres. That's how I work with. And in this case, you add here one more field, again for builders, but that will be map of key value for your JSON file. There is huge disadvantage, like you need always control. You do not any more control what exactly inside this JSON. You can't validate schema anymore. Yeah, but if you need dynamic key value insights, like you can go this way. Sometimes you need. That's my ideas to answer this question. Is it good? Let me know.
Sorry, I'm not sure if I understood correctly. So you're saying that even with using that, even when we have to pass the attributes dynamically based on the scenario, we can still use the builder pattern. Is that
Yes, yes, because you anyway have ID of the whole column, and this will be the field. Maybe some attributes wouldn't become dynamic, but you would understand, okay, that should be as a column in my database. So that will be name, for example. But others could sit in one column that has dynamic attributes. That will be separate column for this. So database should understand this is a column. This has, again, example, JSON being Postgres. There could be different examples in other databases. But I to database knows that this is data that's from this dynamic attributes values.
okay? Thank you.
Okay, good. Yeah, so that's my notes. I think in Java you don't need interface because you have internal, at least internal classes, and I do not remember how it says in C++. Please correct me. They also have internal classes, but ideas behind patterns in the beginning, it's even before we had Java, even before we had powerful languages. So keep in mind that when you look at classic diagrams, you look at diagrams for languages that were developed 50 years ago, 60 years ago. So they didn't have all features that we have right now inside languages. So in Java, Builder could be easier than class diagrams that you will find out if you Google classic Golf class diagram for Builder pattern. Use static in your class again, because then you use public static function builder and name it product. That will be my tips to have this pattern to be implemented beautifully inside your Java application. And let's cover the last creational pattern. Today we really hit all creational patterns in one. The one is called prototype. So when I saw so many patterns, 23, I thought like it's impossible to remember all of these. But 5 of them you can remember today. At least creational pattern, it's easy to close. And prototype is the easiest one because you don't need this pattern anymore. Prototype is implemented as a pattern for languages like C++. The problem with those languages that they didn't have copy method inside language. And then appeared 2 languages built in C language, Java and Python. If you will try to go to native function of Java and Python, you will find out that actually they implemented in C because both languages built in C. So we have now, and this track is about two model languages, Java and Python, and you don't need prototyping them at all. But again, forget about classic Gauss diagram, unless you work with C++ language. If you work with C++, then you need to go through diagram, implement copy pattern, copy function as prototype pattern, and again, everyone would understand what you meant. That's the best thing about design patterns. Like when you don't have this as a functions prebuilt in your language, you can use pattern, and everyone understood like you meant copy of some object. That's what you meant. So prototype pattern no more than just copy the object to another object. And let's say, don't forget that you need to do deep copy for complex models. Yeah, so you use, if you work with Builder and if you work with data models like product, you actually should use copy every day, which is needed. Builder and prototype patterns, that's basically you use every day. And copy as prototype, we use here, like, that will be my setting, which to use it as private builder copy method, which build you deep copy, and then you'd say what exactly you need to update. Because if you create the record with some ID, you should never change this ID, right? Or for example, you say, my name is sealed forever. I have product MacBook, like some series, some other attributes. I can only set discount. But you set discount by having, first of all, deep copy with all attributes under the hood, and then you update only discount. Let me know if it makes sense. So that's your implementation prototype. Basically, you do prototyping is about cloning objects, and that's could be done as a public method of product update discount that give you new product, and then you save this new product. Okay, any questions? Is it good? Is it clear? Is it easy? Readable? Let me some reaction. Okay, Pratna?
So essentially, we might have, can we have a class, a builder or a static class, not necessarily a builder, and that can be used to create copies?
Yes, you can.
Okay.
You can, but why would you do it if you have already copy? You already have copy as something that Java gave you.
Ah, okay.
Yeah. So here we've put, here we've put new method, entirely new method that's copy through the builder. Yeah, we put it as a bit more powerful way. You can have separate class that will do copies, and that will be more proper implementation of prototype. However, you can keep it on product, on the model level, I would say, because your model, as we discussed, and thank you for this question, your model can do some business logic as well. Like, why just put it in separate class if model itself knows how to copy itself? At the same, like, object in Java knows how to copy itself if it's complex logic or complex object again. Give it more implementation to copy all fields. Do not rely on default implementation. But when we're talking about business objects, we can say, like, we can use Builder for this. So we implement copy by ourselves, but it would be on the level of our product. So we don't need basically another class. Yeah. Theoretically, you can put it in another class as well. Okay, so now.
Just to understand this better, so this particular example would actually do the modification on the existing product, or it will create a new instance of the product and update the discount. So if I talk about, like, I have two products, and if I have to update the information on that product, then I should use this. Or if I need to create a new product with the information from the old one, then I should use this.
You will get new product because ideally all your objects are immutable. Yeah, so you can't just update product. You can only create a new one. Immutability across the whole application gives us much more security and stability. So we're trying to keep our objects to be immutable, which is why you can't change. Like ideally, you design your data models, like you can't change objects anymore. You put them to be immutable. So risk copy is private here. And update discount give you a new product. So previous product that you get from a record from database, you update it with new discount and you save it to database. And then you forget about this object inside the application, and there is a new record. And the mutability gives us threat safety, yeah. So we can think about product as single. We can change its state. We can only create a new one and save to database a new one. Otherwise, we may end with issues. So that's the example of do not like bad usage of singleton pattern. Here you can create one product and then change variables because another thread will change to another discount, and it's not clear what discount we save in database. Yeah, so that's, by the way, this is an example where you don't use singleton pattern for product here. Use builder prototype, like of this area of data and return a new one. So it's an interesting way to think about it. Here we say we don't think anymore as prototype, but we think about how we guarantee immutability of our objects. How we guarantee that we can't mutate them. We only create a new one. Yes, Nami?
I have actually a question regarding, the retrieving the object from database and updating the property. I mean, in the context of Spring framework, I have seen many code examples. Personally, I have also used that, the transactional annotation and find by, and I retrieve the, let's say, product from the database. And since the entity is in the managed states, I just update the property, right? But I didn't use exactly the copy of it. So what's the best practice? I know that Hibernate has transient, the object definition, but in this case, what's the better practice to apply? I mean, you said that it's better always use, the prototype in terms of, the immutability definition, but I'm a bit confused in those cases.
So if you use Spring Framework, Hibernate, you maybe use other frameworks that's already hide this behind even this one. I would be happy to exchange some examples and to see like what exactly practices that you follow, because I can admit that maybe in your case you already follow pre-built mechanisms that guarantee immutable objects. Yeah, this is for raw core Java. Like if you don't use any framework, you can go like this, because you also can use Lombok, right? And Lombok annotation builder will create builder for you. But here you look like how exactly it looks like. how this builder under the hood built for us different fields. Like if you use Lombok, you don't need to build all this code. You just put annotations there and you just add fields and that works. Because before compilation, it generates all this code base. And it's interesting then to go to precompiled code base because Lombok put there all these things that's like, I don't know, writing code for you before compiling it in runtime. If you open runtime, you will see what Lombok did with the code. And we never put Lombok in runtime jars. We say like we use them only on compilation time because runtime code, it doesn't have annotations from Lombok precisely. It has plain Java generated code. So let's exchange examples and I will see what exactly you're using and I will let you know. But this is like the one if you don't use any frameworks. For example, Juke framework for saving data. Again, for database in Java, it doesn't have these annotations. So you should more control your object by yourself. That's how I will explain it. You can write a lot of things on core plain Java that frameworks. And it will take time, but you will control by yourself. That will be your designs, that will be your ideas, not given from frameworks. But the best practice, well, it's arguable, like what is better, frameworks or your own code base that you control. Like we see right now in the world where like languages evolve and frameworks, they also go through this evolution. So they becoming better. They becoming better and better and better. So it's becoming more useful to go through frameworks as well. But it's very important to understand what is under the hood and what is foundation, what's the idea. So as I said, right now you don't see abstract factories and factories if you use Spring Boot because you just have annotation, you just have annotation repository, annotation service, annotation controller. Everything built it for you under the hood. You have very small code base if you go through these frameworks. And in our YouTube channel, you can check our video about Spring Boot applications from Adrian. If you'd like, you can also watch. If you didn't work before with it, you can watch. She explains the concept behind Spring Boot Java applications. Okay, are we good now? Okay. Yes, so here is how we build products under the hood, actually in main application, for example. So here it's use new product builder. Again, if you use static in your class, you can do this like this. Without static, you won't be able to access like this for new product builder. And again, my recommendation will be even encapsulated with public static method that will be just product set ID, set name, set discount bit. If you use Lombok, you just put annotation build and then you just build. And when you do discounted product, you say original product now have discount 20% instead of 10. And basically that's it. Before we move to Python, any last question for Java models or C# models or C++ models, because we are going to go through different direction right now. Okay, 1, 2, 3, let's go. Let me know, who of you know what is first-class citizen in programming language? Maybe you've heard about it. It's fine, many years ago, my friend shared with me. We were explaining all these ideas. And I don't know if I would know it without my friend, to be honest. But he also gave me this George book a book effective Java told me, if you want to understand how to write it in the beautiful way, you should read it. And it's like, I read it and okay, like, I don't understand, could you explain this point? So yeah, I know even because of collaboration. So today we collaborate to learn what is first-class citizen. And now we're going deeper to languages. That's why we think about it. It's basically the content, first-class citizen, who is first in our application. And that's referred to two things, objects or functions. So that gives us idea that some languages, object-oriented programming languages, like Java, C++, C#, and some languages, functional languages, like Pascal, like Scala, they have both, like Clojure, I think it's functional. And this is mean like what we can assign to a variable. Is it object or is it a function? What could be passed as an argument to a function? Could it be object or function? Could we do function and argument function? What returns as a result again from function? Could we return function as a result? In Java, we return objects, but could it be functions? And store it in data structures. Again, like could we put list of functions or could we put list of objects? The same for maps. So for objects, it's clear. Its objects can be stored in variables, can be passed, can be stored. And I put example in Python because Python have object as first-class citizen. So class doc give us object doc. We initiate this name. We create first object doc. We create second object doc. We create list of docs, and we can print doc. But even in this example, I would point that to print doc, we didn't have to create an object. You see, there is no object that's responsible for printing doc name. No object. Because Python also first-class citizen function. Basically, Python about bots. And when we're talking about functions, which is JavaScript, if we have here JavaScript developers, and hi Isabel, this section for you. We think about functions that doesn't have to be part of object. And now think about it. Java was built as an object-oriented programming language, which says you can't invoke even a function without having in place an object. So all your functions, starting with main functions, and the main function is a part of main class or application class or my class or my first Java application, yeah? That you always have first ever class. First ever class, which is the object that we'll be creating, and the main function to execute the program. That will be function of this object. So in Java, you can't even start with a program without having classes, unless Java 9 gave you script interpreter. Like you can start interpreter fine, you can write something in Java without having main class object. Yeah. Yeah, Isabel sharing that she did Python Golang, but JS really okay. And Denise says that this main pillar in JavaScript function first-class citizen treated like an object. Yes, so in functional, like purely functional languages, you should forget about object as idea. You have still variables, but they are not objects. And I would say it's very hard if you program in one application in object-oriented language, and then you write another application in functional, and if it's in the same company, your brain's just like, oh, it's really hard because it's absolutely different contents. How you do everything, create program, establish it, etc. Excellent, excellent note from Nermi that functional programming style in Java appeared after Java 8. So they did the trick. They felt like actually we need to add lambdas, and C++ also added lambdas. I don't remember who was the first. I think who in C++ was the first who added lambdas, which allowed you to assign function to variable, pass it as argument of function, return from the function. Yes, I think you can return lambda as well in the done, but yeah, you can do this for Java now as well. Under the hood, it's actually object, and that's quite tricky idea as I use anonymous function, anonymous interfaces. They couldn't change that much language. They still have objects, but now they said actually we found the way how to do and treat this object as function. So that's anonymous classes, but they found their way, they broke this. And they said, now we also have first class citizen function. This is under the hood object, but don't think about it. You now can use lambdas. That's called lambdas in Java. And now you can use patterns for functional programming in Java, which is monad pattern, for example, in strings, and we won't talk about it. Okay. Let's see how example for functional is function for citizen looks in Python. Yeah, we have function greet, hello, and we say that we assign to variable function, which will lead us to another idea that will come. We print function. We basically print a function. So we see carrying here. You know about it, like that's basic example of carrying, which is functional pattern. Execute function with another argument. That's again like carrying idea. And so basically you can do whatever you want this function and return them as well. There is no example of returning. Yeah, so in Python we have both. Basically, why we decided to do step forward, not forward, but step aside, because we wanted to say basically Python has two paradigms. So that's not only object-oriented, but that's functional as well. Because it's object-oriented, you can implement all object-oriented patterns in Python. But guess what? We don't do this for all patterns. So basically, the question that I asked myself, is it true that some programming design patterns could be used in both first-class citizen functions and first-class citizen objects languages, but some should be used separately, like some shouldn't be used? And let's look at it more closely. So patterns adaptable for both. Strategy, we've talked about it. Observer, common pattern, we will talk about common next. Template method pattern, chain of responsibility. That's basically for both languages. Now we have functional only patterns, monad pattern again, and function composition and card. So where we can put function in another function basically and transform functions between each other. Okay. And we have object-oriented only patterns, which is factory thing, not prototype builder. Mediator, we'll talk about it at some point. But as you see, suggestion that factories, abstract factory and factory method, and singleton and prototype and builder, we shouldn't use it for Python, even if we can, and we can, because Python object-oriented programming language. We can do all these ideas in Python. However, we wouldn't. And let's go first on singleton. So I put source here. As soon as you read and went through object-oriented patterns in this Head First book, you can go to this website, sources here, and you can read how we treat them in Python, like how community decided to treat them in Python. So for singleton, and spoiler for many, the same, for many patterns the same, they say like, okay, actually, we wouldn't do this. We use instead of it the global object pattern. Now let's be fair. And as we committed in the beginning of the course, we will give you examples in Java and in Python. We will be very honest with ourselves and fair and give you proper examples of Python. So let's start with global object pattern. Yeah, it refers to pattern where a single globally accessible instance of an object is used across the entire program. And here is the most important part as a model. Oops. So for me, it's like Java developer of decent years of experience. Model is something that model is something that I never used in Java because we don't have models. We have packages, but it's not models. We import from packages, but it's not models. It's absolutely different idea. So some ways it's resembled a single pattern, but it's simpler, much simpler. You don't need this private instance, etc. You basically use these modules to guarantee that there is one instance from this model. That's it. That's so much simpler. And let's look at simple example configuration. We say that this is config.py, and we say this config.py has variable config, which encapsulate object config. So when we use it in our main application.py, we say from config, import config. And then we connect the database by using config database. And that's it. That's it. We basically used no private constructors, no static instances. You don't need anything from different patterns, from singleton. That's it. That's how you use singleton in Python, global object pattern. Let's talk about our repositories. So I was thinking as Java thinking, okay, like how it looks like. So we have repositories that have get all, get by ID. Then we implement it through extension with product repository. And then we say product repository variable is product repository. That's it, singleton. One instance across the whole application. And we just get all, get by ID, and print all products. If you have even better examples, please share with me. Please share this channel design patterns course if you can, like, there are even better like examples or your examples. Again, like for me as an analyst and Java developers, it will be very useful and insightful to see how we can use the same ideas in Python. The same for user repository, it's just different model. So the whole idea, and that's amazing. You don't need abstract factory anymore. You don't need abstract factory methods, any factory methods. You just put in initialization and installation of variable of this class through this model, and that's it. And that's the same for database connection, for database configuration, for everything you want to be singleton. You just use it as a field repository field. Wow. And let's see how it looks. Yeah, that's it. We just import them. No, again, abstract factories, no factory methods, no singletons patterns. Now, let's think what's happening with builder and prototype. For prototype, the most cool thing that it already exists as a clone method in Python again. But now, we have very cool and powerful ideas defined functions. These functions in Python could have default default values, and we can define which exactly we want to provide. And here we don't care about order, because we can say, even if we have ID, name, discount, expiry date, when we construct our product, we say, whatever order, discount is new discount, and discount expiry date itself, like another discount expiry date. We say ID we say name, but we say what variable we assign to what. And because of it, we don't have any more problems with constructors like in Java. Basically, we don't need any more builder as a pattern. We just say we will build it with variables that we know about, whatever we want, whatever, like how we want. No builder anymore. And for prototype, it's the same. It's something like, okay, we can clone them, and we can say which one. Instead of having this copy, builder, etc., we just have clone as a method, and we just say which one we want to clone. Yeah. And that's it about that's it about all these patterns in Python. Yeah. So what? How we use it? We just say product.com new discount. Yeah. Just another one, product.com. The only thing that we need to think that we still provide our object to be immutable. So we always create new product. So what we want to guarantee, whatever language is it, immutability, and still singletons, just it could be different ways to be singleton. Yeah, so we still think about patterns, but we think what exactly we guarantee. We guarantee that we have only database connection only once. We guarantee only one configuration, whatever we do with raw models, or we in object-oriented programming language we implement pattern, and we would like to guarantee immutability of objects. And those two concepts, they remain the same. Okay. Now you're ready to build application, any application. And we will go one day to model view controller pattern, where we will look at these concepts again. So please keep with us. And for next, let's read about common pattern and adaptive pattern. Cool, that was a journey. So we talked already about strategy pattern, observer, decorator, and today we covered all creational patterns. Okay, so resources, you can look for fun at this design pattern. I looked for fun over the weekend, and that's very funny. I mean, let's use examples of small talk languages, programming languages, and refer to these to understand them, to understand better. And it's funny because no one, like, it's that language. Again, at first design patterns, and you have link in our channel to even more modern, colorful edition, and consult with Raccoon. We didn't consult today, but because even without it, it was quite an intensive session. But yeah, and presentation, I will share it in Slack. Okay, if you have any questions, if you would like to discuss ideas behind creating the application, and one more note, today we didn't cover system design because all this creational pattern, it's about creation application by itself. So when we think about system design, we think about our services, microservices, how they interact with each other. That's why we can think about behavioral patterns as patterns that right now come to system design level instead of being in one monolith many years ago. But for creational patterns, we keep it simpler. We anyway spend a lot of time to discuss about them. And we basically don't have analogies with system design, because system design, how microservices interact with each other. While creational pattern, how would you create these microservices? How you make them stable, maintainable, easy to implement, easy to support? How you would avoid mistakes? How would you make, again, immutable objects inside, so you wouldn't end up with inconsistent state in database? Yeah. And how would you make singleton instances do not have leaks, threat concurrency issues, nothing? So how you will just build the application to be neat and running well. Okay, yes. Thanks a lot. I stop recording right now.